Okay, year 10. So this is our first remote lesson, and we're going to be having a look at a new topic for most of us. If some of you have done this, then please use it as a recap. We're going to be looking at acids, alkalis, and indicators, and the pH level and what it means. So, how can we determine the pH of a substance? Fairly straightforward by that picture. We can use something called the pH scale. Okay, as we move left, the substance becomes increasingly acidic. If we move right, it becomes increasingly alkali. Now, the reason for this scale is when we use indicators, they actually change the color of the substance or the object to allow us to determine its acidity. Now, very, very quickly, I'd just like you to have a look at those items on the left and see if you can predict whether they would be acidic, neutral, or alkali. Give it a go. I'll give you 30 seconds. Cool. So, hopefully you've done that. If you haven't, hopefully you'll be able to by the end of this lesson. So, in the red box, there is the definition of what an acid and an alkaline is. So acids contain a source of positively charged hydrogen ions, whereas alkalis contain a source of hydroxide ions, and they are known as soluble bases. Now, the purple question there is which of these are polyatomic? Now, hopefully you will remember that diatomic means that it is made up of two. So give it a guess. What do you reckon polyatomic means? Yep, well done. It means that there is only one, so it would be the acids. What I would like you to do is to pause the video here and just copy this table into your books or onto a piece of paper, as it will help you to remember the colours that alkalines turn with different indicators. So we've got litmus paper, we've got methyl orange, and we've got phenolphthalein. Okay, as you can see, in an alkaline solution, litmus will turn blue. In an acidic solution, it will turn red. Methyl orange will turn yellow in alkali and red in acid. And finally, you get a pink color and it goes colorless in acid. So on this page, you'll see just a few entrance questions. Pause the video here and give those questions a go. Make sure to write the questions so you remember what the answers refer to. Okay, let's see how we did. On the screen now, you will see that the neutral solution pH level is 7. It will go red in acid. I can't say it now. Phenolphthalein will go purple, if you remember from the previous, pink from the previous screen. What is the name of a soluble base? It is an alkali. And methyl orange in an acidic solution turns red. So, very, very briefly, I would like you to write in your books or on a piece of paper what you know about this. What is it called? So pause the video again and off you go. Right then, year 10. So as you can see, acids have positively charged hydrogen. I'm struggling to talk today. I'm so sorry. Acids have positively charged hydrogen ions, and alkalines have a high concentration of hydrogen oxide. So Concentrated and dilute. I'm sure you all know this, and you've probably seen an example of this when you've been making squash at home or something like that. A concentrated solution contains a large mass dissolved into a given volume. So a concentrated acid contains a large mass of acid dissolved within a given volume of a solution. Dilute acid contains a smaller mass of the acid dissolved in a given volume of solution. So to calculate this, we can use a very simple equation. It is the amount dissolved in a volume of solution. So we use something called a decimeter to identify the volume. So grams, or units, I should say, excuse me, for concentration is decimeter cubed per gram, or grams per decimeter cubed. Okay, a decimeter is the same volume as 1 litre or 1,000 centimetres cubed. So have a go at calculating the concentration of this example. So 4 grams is dissolved in 50 centimetres cubed. So observe that note there, look, a centimetre cubed is divided by 1,000 to change it into decimetre cubed. So we quite simply do 4 grams over 0.05, which will give you a concentration of 80 grams per decimeter cubed. Have a go at these questions, work through from bronze until gold, and see how we do. So pause the video and off you go. All right, hopefully that all made sense to you. So strong acid is one that completely dissociates or splits up into its separate ions when it is dissolved in water. So you've got hydrochloric acid, which is an aqueous solution. Okay, if you add that to water, it will dissociate into its component parts. So you'll get the positively charged hydrogen ions and negatively charged chlorine. Obviously, they would both still be an aqueous solution. Once again, guys, it's in a red box, so please make a note of it. Now, strong and weak acids. Okay, as we said, a weak acid will only partially split up into its ions. So an example here, we've got the aqueous solution and it doesn't completely dissociate or split. Make a note. Okay, so hydrogen ions and their pHs. So the concentration of the hydrogen ions in an acid is linked to the pH. So as the concentration of the hydrogen ion increases by 10, the pH decreases by 1. So as you can see, as you move down the pH scale, the concentration of the hydrogen ions actually increase. Now, I attached a worksheet in, oh, sorry, I've uploaded a worksheet, sorry, not attached, for you to complete. This is where I need you to stop and complete that worksheet for me. So pause the video and give it a go. Right, when you've completed that worksheet, what I now need you to do, guys, is to have a go at this exam style question. So read through it. I would like you to answer in, obviously, full sentences. So you're going to need a couple of paragraphs here at least. And we'll see how you do. So pause the video, give it a go. Right, I've just put up the mark scheme there. So which two solutions have concentrations of hydrogen ions that differ by a factor of 10? If you have a look, M is pH 3, J is pH 4. Okay, we've moved down the scale, so the number of hydrogen ions have multiplied by 10. So there is your answer. Okay, state and explain which solution can be a concentrated solution of a strong acid. Okay, remember, as you move down the scale, the pH drops. So N will be the concentration or the concentrated solution because it contains the most acid molecules. Okay. Again, it will break up to produce a higher concentration of hydrogen ions, and the higher the concentration of hydrogen, the lower the pH. So if you've got both of those in, well done, you get 2 of those marks. Right, I hope that made sense, guys. If you have got any questions, just give me a call or drop me an email, I should say, and I'll be more than happy to go through things with you. Enjoy your day.